Hello and welcome to TidyX episode 61. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at @OSPPatrick. And you can find Tidy Explained on Twitter at Tidy_Explained. You can email us if you prefer, tidy.explained@gmail.com. You can like and subscribe on the YouTube channel and comment there directly to whichever video you had questions, thoughts, or comments about. Or you can go on to the GitHub repo and take up an issue if there's something that you'd like to see.
And we can discuss it on GitHub and really go over it and hash it out and see what you really want to see here.
Yes.
All right, episode 61. So in this episode, we're actually going to be talking about regular expressions and starting a series on data cleaning, because that's kind of something that we've kind of got,
It sort of starts out every one of our scripts, right? We have to get data. So there's always some form of acquire data, clean it, and then we can get into some analysis or visualizations.
Mm-hmm.
So, Ellis, what are regex expressions?
What are regex expressions? So regex expressions are regular expressions, which they're anything but regular.
Indeed.
So it's a way to tell so there's a series of functions and utilities that exist where you can pass a string to it, and it'll then search through other strings to find a pattern. And there's a specific form you need to be passing to them, and the different functions perform different tasks for you. And that's a very vague and very high level, probably very abstract description of them. So we will actually be spending today's episode going through the different types, or some base R functions, as well as some common anchors and ways that you can use regular expressions to do this. And this episode is actually inspired by something that we saw on Twitter this week. So a friend of mine, Dean Natali, posted this tweet here going, like everyone else, I don't like regex. I would happily pay for somebody to get this nightmare away from me. I'm trying to do this really weird thing here. And indeed, what he was doing is pretty strange. He's trying to remove the comma after this one row here. It's a very not common regular expression. And of course, the Twitter community kind of posted a bunch of different solutions here.
But I think you need to share your screen, though.
Oh, you're not seeing it. Everyone else.
I don't see it. Maybe nobody else is seeing it.
There we go.
They're watching you talk about it. There we are. There it is.
There we go. All right. So yes. So Dean posted this. He came up with some solution. Joe Chang came through with this very scary but also very powerful regular expression here that I looked at, and it looked like wizardry to me, but I believe that it works. And he actually posted an explanation on how it works, so you could definitely check that out here. We can post a link in the description below explaining how this ungodly regex works.
Yeah. Crazy.
We're not going to go into that. We can
put the link in our script, though, for anybody who wants to check it out.
Definitely. Yeah. But what we're going to do this week is go through some basics of regex. So we're going to call it a regex 101 here. So you might be able to start looking at what he does and did and go, I see it.
Yeah.
I understand. Probably not, though.
Yeah, it looked pretty crazy.
All right. So let's get going here. Yeah. So now that we've blathered for a few minutes, so the functions. So base R, they include some very nice utilities for regular expressions, and really regular expressions are for string manipulation. So you get a string in and you want to manipulate it in some way. You use regex to do that. And so in this case, we're going to be focusing on base R, and so we kind of went through them and separated them out into a couple different types of functions that exist. So there's the grep and grepl functions. So those are for searching through a vector of strings to tell you whether your regular expressions exist or not. So it'll return, so grep will return the index or the value. So you can type grep some pattern, so the string you're going to be searching for, pass the vector into it, and then it'll go, oh, this exists in these indices in that vector.
Yep.
Or you can actually, so we've got the help page over here, you can actually set the argument value to true, and it'll return the values themselves, so you don't have to search through it yourself. Then there's the grepl function, which is exactly like grep. However, what it does is it returns a Boolean vector of true or false. So it doesn't return an index or values. It just tells you, hey, I searched through this string. Here's the it's false, 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 true, false, false. So that means in the third index of that vector, it matched the pattern you're looking for.
That's a super useful one, because if you're looking at a string, like let's think about an example. Let's say we're looking at a column of basketball lineups for a team, and we want to know whether or not Steph Curry is in each of those lineups going through the game. Let's say the team played 20 different lineups. We could set a grepl to say if else grepl Steph Curry is in lineup string, give it, or no, we don't even need the FL. Sorry, it'll just give us a true or false, and then we could sum that, and we could say Steph Curry played 40 plays this game, or whatever it is. Yeah.
So it's super useful to do that. It's really great for summarizing information or just giving you like a high level look at the string content that you're dealing with. And often as data scientists, we're going to be dealing with strings a lot in descriptions, and they're not going to be formed in a nice way where we can pull out the stuff very cleanly. And this is where regular expressions are really useful. Patrick, what are sub and gsub?
Substrings are for string manipulation, where you're actually trying to identify a pattern and then substitute something for it, right? So you'll see that in the example here. Sub is going to replace the first instance where this occurs within the string, and gsub is going to replace all instances where whatever the incidence that you're looking for occurs. And you'll see an example of that in a second. Some of these things are like, when you try and explain them or read about them, they're super non-intuitive until you actually try it. Like, some of the best ways I work on regex is I just literally make I type a sentence, and then I just try and work on parsing it out before doing it on a data set, because it's super non-intuitive at times.
I mean, that's exactly what I do too. So actually, that is a nice little segue, little break over here. I use regex101.com all the time whenever I am working on a regular expression, because usually I'm writing some weird, funky expressions where there'll be like really weird stuff that I've got to I want to identify this case here, but not this case here. How do I make it so that it'll do that? And it's really nice because it allows me to write out the regular expression I'd be using, and it'll tell me how it's behaving on it. So I can work through this problem and really try to understand what's going on with my regular expression, and then move it over into my my R session and actually use it.
This is an amazing website. I've never seen it before until about 10 minutes ago. So I'll definitely use it. Regex 101, pretty cool to use, and saves a lot of time from Stack Overflow searches.
Exactly. They've got all the explanations of all the different anchors and whatnot that exist.
The other two kind of functions that base functions that we have before we get into our our regex keywords and our anchors and stuff are substring. So that's if we're trying to extract out like a specific location of some sort of string within the variable. So I'll give you an example. Let's say we have a column of dates that say like 2020-05-26. So May 26th, 2020. And we only want to get the year. We could actually pass over that column substring and just say, give me so in this case, we want the last four. So the start and stop, we want to start at the last four in the fourth spot. So that's 3, 4, 5, 6, 7, number 7. So start will be 7, and stop is going to be 11 or 12. And then boom, we get 2021. And so then we have the year. automatically. The only kicker with substring, and I'll show you an example in a second of where this goes wrong, is you have to be very confident that the column you're parsing over is always in the same way, because substring is sort of like a stupid function. It just says, okay, you want to start at character 7 and you want me to go to 11, and I'm always going to pull whatever's there. So if you're doing years and something isn't there that's supposed to be there, you get in trouble really quick. So that's the only thing with that. You have to be pretty confident of what's in that column.
The things aren't moving around.
Yes. And then string splitting is
This would automatically break it because now
totally
it's not grabbing the right stuff here.
So just got to be confident. And then string split is one we've used before. I'm trying to think when we might have used it. But anyway, this is another kind of like extraction type of function where you're actually trying to split the string based on some sort of character. So maybe splitting on the hyphen, and then let's say we only wanted the year, we could actually run string split and put a bracket at the end that says, yep, there we go. And so now we have our year.
It returns a list, and so that's always something that's a little funky. But the reason that it returns a list is because you can pass multiple strings to it.
Correct.
And so we could do this, and then...
You just have to always make sure that... go ahead and run that.
We get that, and then so now see why it's a list though, because these don't necessarily have to be the same length, because it could have some additional pieces there.
Right.
So a list is the most general way to store all this information.
Just make sure that you're passing characters. If you pass a factor, which can look like a character, string split won't work, and it's going to throw up an error at you. So yeah. There you go.
Here, we will real life demo that for you.
Oh, it's not a character argument, so just make sure you do that.
Okay.
Sad trombone.
All right. So you may have seen some stuff when I was showing regex 101. I had no real words in my regular expression search. And that's because regex they have keywords that exist in it to tell the function how to start behaving, so it doesn't just dumbly, or you can pass more information rather than just look like in Patrick's example, finding Steph Curry. Maybe you want to know what are all the times that Steph Curry was listed as the first player on that list, right? Because that indicates something. Like this would be like cases where the order matters.
Yeah, right? Let's say ESPN or NBA.com always listed as point guard, small forward, power forward, shooting forward, and then center. You want to know if Steph Curry is in like the point guard or the shooting guard spot. Like that might mean something. It might. Yeah. I don't think it means anything for Steph Curry because of how he plays. But if that were the case, that might mean something.
Yeah, I was just going off your example here. So regex allows for you to pass keywords to it to allow it to more intelligently search through the strings and not just like, oh yeah, I found this. I mean, it does that. It can do that. But you can then glean more information out of it. And so those we're calling regex keywords. They're also maybe called tokens. But so if you have the upwards caret, that is going to tell the regular expression, okay, start searching for this at the very beginning of the string. Or anything that I type after this is based off of the very beginning of the string that I pass, that I'm going to be searching in. Yep. A $sign means, okay, base everything, anchor it off of the last end of the string, not last, the end of the string, and then search to the left, essentially. And so there are cases like you might, once again, in the pattern there, you might want to find when Steph Curry is the last player. And so you might search by this. And so this would look, and if Steph Curry was listed anywhere, if it's spelled exactly like that, if it's listed anywhere but the very last, it'll return false. It didn't find it. Once again, this is very ephemeral or very theoretical until you actually see it, and then it kind of clicks. Then there's digits. So this is identifying any numeric value. So that way you don't have to type 1, 2, 3, 4. You can just say, okay, I want any digit. White spaces. So as if we work with strings, we all know that there are space. So white spaces are really spaces that you see. So in that Steph Curry example here, this is a white space. And there can be multiple white spaces that exist. Or it could be a tab. That would be still considered a white space.
Right, or a new line.
Is new line does white space capture new lines?
I believe it. If I remember correctly, I believe it does. I could be wrong, but I believe it does.
So let's just do a quick search.
There you go.
So /n is new line. Yep, there we go.
Yep, there it is. It does, yeah.
There we go. So it does identify new line characters as well. Then there is alpha W, which is any alphanumeric words. So any words, so any set of characters without any spaces, it's happy with. It'll identify that. There is the dot, which is literally anything. It's like the catch-all for, you know that you don't know what exists ahead of time. You know that there's some string in the middle that you care about, so you type that out, and then you don't know what's after that. And so you can use the dot to identify that you don't know or care about the stuff that's around there. All you care about is this small piece in the middle. So those are like matching tokens. Then there's these, okay, well, how many times is it supposed to match? And this is done with an asterisk, a plus, or a question mark. I tend to use the asterisk or the plus. So what an asterisk means is you can match this pattern 0 to infinity times. So if you're looking through your string and you're like, I don't know if this is always going to exist, but it does in these cases, and I want it to work even if that pattern ahead of time doesn't exist, you'd use the asterisk. With the plus, it is, I know, I require it to exist at least one time. It must exist. It could match 3 times, match 5 times, that's fine. But I need it to match at least once. So you can like use these to kind of toggle and really hone in on your search or your expression here. Then there's the question mark, which neither of us could really I can see a value in it. Yeah. But I don't think I've ever actually used it.
I can't think of a time that I've used it. Although in the example that you gave at the beginning on Twitter, there were a few question marks in there.
Yeah. So
so I probably need to read that GitHub repo and see why was it used.
Yeah, exactly. Yeah. Okay, so that's matching. And then there's matching explicitly or exactly, because you can match a different number of times, and you use that with the square braces. How do those work, Patrick?
Yeah, so the square braces are going to basically say anything within this brace is what I want to match exactly. And similar to what Ellis just talked about, we can make this really simple. Like, let's say we've got an alphanumeric string, and we only want the alphabetical words or alphabetical characters within that string, and we only want them, or we want them whether they're uppercase or lowercase. We can put inside our brackets A to Z, basically saying any alphabet, capitalize, and any alphabet word, character, lowercase. If we only want lowercase, we just get rid of the uppercase, and that'll do the same thing. If we want, let's say in that alphanumeric string, we only want the number characters, we can do that by saying inside of the brackets, explicitly stating, look for anything that's 0 to 9, and that'll work. And then finally,
to be like 5 to 9,
or you could exactly whatever works, whatever you are trying to match. And then the last one is, and this kind of happens a lot of times when you deal with people who are typing data into a database, especially if it's like text and things like that. Sometimes they can spell words or mistype words with upper and lower case. So in this example, let's say we're looking at NBA data, which is what we're going to look at in a second here. And we want to look for the word shot. And let's say from 2000 to 2010, ESPN always typed into their play-by-play data the word shot with a capital S. And then let's say from 2010 to 2020, they changed that and they said, we no longer want to do that. We only want shot to be typed with a lowercase s. We can say, hey, if we're looking at data from 2000 to 2010, we don't care. We know that the word shot means a shot was taken. And in this case, we're going to look for any time it's exactly the word shot with either a capital S or a lowercase s. And so that's the example that you see there.
Okay, all right. And then the last thing that I'm going to touch on it very briefly is parentheses, and that's identifying grouping. And so you can use this to write like regular expressions within regular expressions, and you can then use that for later work and later GSub work. I don't really want to go into it because it's very confusing until you see it in action. And then you're like, I get it.
And we have an example here.
Alrighty.
Let's scrape data.
We've talked enough. We've talked for about 20 minutes now about regular expressions without actually showing you anything and telling you we will. So we're going to do that now. All right. So we're going to load in tidyverse, lubridate, and rvest for us to then have data manipulation stuff, time manipulation stuff, and web scraping stuff. We're going to set the ggplot theme to theme light, though I don't think we actually do any plotting this week. And then we're going to do some web scraping.
Let's scrape away.
Which, do we want to go into this? Or I think we've covered web scraping a fair amount.
We've covered web scraping a fair amount. This is literally the first game when I opened ESPN.com on the NBA side that I saw. So that's what I pulled. I literally pulling the first quarter of this game. Not because I didn't want to scrape the full game, but mainly because we only need a few rows to really show these concepts and kind of help everybody understand them at a 101 level at the very least.
So in summary, what we're doing is we're taking this table and pulling out the information and going to generate a table. So we're going to read the HTML. We're going to scrape out the first column, which is timestamp, convert it into a table. We're going to take the second one, and here we actually do a bit of regex, so let's go into this a skosh. We're going to take the ESPN HTML, we're going to pull out that logo column, which actually has an image HTML. So what we want to pull out here is the team, which team has possession. And we do this by looking at the logo, source. So let's take a quick peek at that. So what that is a long, ugly URL. But you can see here, MIL standing for Milwaukee and MIA standing for Miami. And that's what we want to keep there.
Yep.
So what we're going to do is we're going to use a GSub. So remember, GSub is string manipulation, not identification. And what we want to do here is we're going to use a dot asterisk, though we probably could have done a dot plus, to go, okay, I want everything up until this pattern here. So it'll take all of that. It's like, okay, cool. And then if this changes, if it got shorter, like say this got deleted for some reason, or like the URL changed, it doesn't care. It's happy. Then it'll go, okay, I want to identify this group, which is what the paren is doing. Identify either MIL or MIA. So that's MIL standing for Milwaukee or MIA standing for Miami. Okay, I want to match that. And then I don't care what's after that. So anything, if that changes length, character, whatever, it doesn't care. It's happy. We just want to be able to identify Miami or Milwaukee, MIL, MIA. And then we're going to use a sub here. So this is the sub pattern that we're going to be doing. And because we identified a group, and this is the first group, quote unquote, even though there's only one, I'm saying, okay, look at this entire string. The only thing I want to keep is group one. So MIL or MIA. Keep that. Throw the rest away. And so that's what we do here. So we can take out.
Oh.
There we go. Let's run that, and there we go. MIL, MIA. And this is exactly what was in the URLs there. I'm going to convert it to a table, pull out that information. Sorry, that's a very high, very quick level. If that didn't make sense to you, please comment in the video below and I can go through that more in depth. But that is kind of rough look at how grouping and an introduction to Gsub works with our anchors and magic going on there. All right, so then we're pulling out play details. So that's just the string of describing the play and the score of what's going on there, which is Miami, I think, and then
Miami, Milwaukee, Miami, Milwaukee.
Yeah. And then we're going to do a bind calls to bind, because we just have a bunch of tibbles that are one column apiece. We want to bind them all together. And so, hey, there we go. We've got team or time, who owns the ball at that point, play details, and the score at that point.
Looks just like the web page.
Hey.
Hey, here we go.
Alrighty. Patrick, what are we doing now?
Let's clean some data using our regex expression. So the first one I want to do, I noticed the score is a character, and it's a Miami score hyphen Milwaukee score. And so I said, okay, let's get that into two separate columns, one for the Heat and one for the Bucks. And so I said, okay, how about if we start with substring? We're going to pass inside of the substring function the score column, and I'm going to say I want the first and the last character to be extracted, which is the points of the Heat, and then I want the fifth character to be extracted, which is the points of the Bucks. And you'll see this works pretty well, but if we were to take the tail of this,
the tail works better, yes.
Yeah, there we go. We get a problem. We have multiple digit scores, so that's where I write ACK. We can't use substring here because, as I talked about in the beginning, if we're using substring, it's always looking at that first and last. So let's figure out a different way to parse this. And the way that we're going to do that is we're going to use gsub. Well, we're going to show both examples. We're going to show sub and gsub. They're both going to produce the exact same result, so it doesn't matter.
In this situation here, because sub and gsub, there's only one match.
Yes.
So it's easy.
Correct. And the key character string in here that we're concerned with is the hyphen. So in this first example for the Heat, I'm saying, okay, find the hyphen, then remember the dot and the multiplication sign, everything after that hyphen, and I'm passing a blank quote, because I'm saying, hey, anything after that hyphen, sub a total blank. Just get rid of it. I don't want to see it.
Including the hyphen.
Including the hyphen, yes. Hyphen and everything. Get rid of it. On the Bucks example, I'm just flipping it. I'm saying, okay, find everything up to the hyphen, and then replace it with nothing. Get rid of it. And we're turning that into a numeric because it's going to stay as a character if I don't do this. And by turning it into a numeric, it's going to conveniently remove all the white space. And then for future projects, we might think it'd be cool to have a scoring differential. So we're just going to create that as the Heat minus the Bucks. And now we have a table that's starting to take shape of something we can, something we could do with it, right? We could use it for it. Now we also see that the Bucks were indeed just absolutely obliterating the Heat at the end of quarter one, 26-point deficit. So crazy. And then the next thing I'll go into is adjusting the time. So look at the time column there all the way to the left. And we see that the time is in, actually, we're at the end of the quarter here. So the time is actually in just pure seconds. If we looked at the head of the data frame, the time is in this kind of funky format, right? It's like minutes, seconds, like if you were looking at a watch or something like that. And that doesn't help us if we're trying to like plot this data or something like that. So the way I'm going to adjust that is using the lubridate package and using some regex expressions. So I'm going to create a new variable called quarter time. And I'm going to use this if-else function, and I'll tell you why in a second. But if you were astute at looking at the tail of the data set, you'll know why. Okay, inside the if-else, the condition I'm first concerned with is I'm going to use grepl, and I'm going to say find the pattern of the colon, and anytime it's in that time column. So remember, grepl is going to return a true or a false. So it's going to say, oh yeah, I found it in these first 6 rows, and that's true. And now in the last, whatever that is, 6 rows or 5 rows, it's actually false. There is no colon. Okay, if the condition is true. If there is indeed a colon, I'm going to use the Lubriday package, and I'm going to turn this into a number of minutes. And I'm going to do that by saying, take the first stuff to the left of the colon, and I'm going to use ms to turn that into minutes. I'm going to add that to the, or minutes to seconds. And then I'm going to take the stuff to the right of the colon and turn it into seconds. And then I'm going to divide by 60. And that's going to get this into a sort of a number of seconds for the entire quarter as we're going down. Okay. If that condition is not met, so those last 6 rows where there's no colon, I'm going to say just take those because they're already in seconds and turn them into a numeric and divide them by 60. Okay. So now I've created this variable called quarter time. And the only thing I other wanted to do with the quarter time is I want it to count up. So time in basketball on the clock is counting down. I want to count up from 0 until 12 so that we know that the quarter ends, because if I'm plotting this, I want to go from left to right. So I'm just going to take 12 minutes minus the quarter time, which is already in minutes. And now we have a new variable called quarter time. And then the other thing that I did was I just threw a little variable in here about the score differential. So I said, if the score differential is less than or equal to 0, the team call is a team color. We're going to use that for like a scoring worm, like we did with Alice Sweeting in one of the old videos. Yeah. We're going to use that later in our next video next week, but we'll leave that for now. But yeah, let's go ahead and run that.
We got that, and it throws in A's because the way if else runs it runs everything and then plucks out the values, and so it's a little obnoxious, but it is what it is.
But nothing went wrong.
Nothing went wrong. We know we checked that already.
So there we go. So 12 minus 12, starting at 12 minutes, means that we're at 0 time, and then 12 minus 47, and blah, 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 as we're working down all the way up to 12 minutes. So cool. All right. Now, what about using regex expressions to identify shots and misses for a player? What do you think?
Right. Yeah. All right. So we wanted to know how many times Giannis, who is the star player for the Bucks, how many times did he shoot and how many times did he shoot and make it? So we wanted to get a in-game scoring percentage, but we don't know anything about the actual game. We don't have the box score or anything like that. All we have is this player or the play details. And we looked at that and we looked at the patterns. We're like, okay, so the way they pattern these, let me pull out a head of, my brain is a little slow right now. Select
play details.
Play details. So this is dangerous, letting me be running all this because I did not sleep well. So here we go. Giannis makes a 28-footer. Bam Adebayo misses. Giannis defends. Giannis makes. So they have a very formulaic way that they describe what's going on, especially for anytime they shoot and miss or anytime they shoot and make it. So that is very nice for us because that means we can actually write a regular expression to search for that and get that information for us fairly easily. One other thing you might notice is it is who takes the shot and then whether they make or miss it. So what we wanted to do is we really wanted to find, okay, how many times did Giannis just take a shot? And so we're going to use grepl this time. So as grepl, you may have noticed that here grepl is used a fair amount, and that's because grepl is incredibly useful. I use grepl all the time, and I use gsub a fair amount as well. But grepl I just use it a lot.
I think those are like the two.
Those are my go-tos.
Most common ones I use as well. Grepl for looking at lineups, true or false if a guy's in it. gsub for removing or changing something within the string.
Yeah.
Substituting.
Exactly. All right. So we want to find all the cases where Giannis is listed first. The very first piece of the string is Giannis, and then we want to find, okay, did he make or miss it, to identify whether he took a shot or not. And so what we'll do is we'll do caret for beginning of the string, find Giannis. So this is locking it in, going, okay, always look at the far left of the string, find Giannis. Then we have the dot star there, which means, okay, there could be some characters between there. We don't know exactly what. It doesn't matter. We don't care.
Yep.
And then it's find this group. So find explicitly makes, in this vertical line, I guess we didn't cover that earlier. This vertical line means or.
Yeah.
So
you've seen that we've used this a ton in case whens or if else's.
Yeah.
And there's conditions.
Yeah. So find makes or misses those exact strings inside of the play description, and then we will mark that as true. You may also notice, so we added this ignore.case equals true, and this allows us to just write everything in lowercase, and it doesn't actually have to match the casing of the string. So we don't have to type Giannis with a capital G. It'll just find Giannis, and it's happy. Okay, now we want to know how many times did he make it. And here we don't want to use ignore case, so we type G capitalized for Giannis. And now we want to find all the cases he makes it. And here we want it to be a little bit more generous. We probably should have done this in here too, where what if they typed make it or make with a capital or a lowercase m? So what we do is we use the square braces there to go, okay, it could be capital M, it could be a lowercase m, but we want an m. Actually, it doesn't matter up here because we have ignore case equals true. Yep. There we go. Big brain right there.
Yeah, that's right. The top one is probably easier and more elegant to look at. The bottom one is an example of how to do the exact same thing.
Yes. Yeah. Exactly. And we could also do that.
G and G. Oh, yeah, there you go. Same thing.
And it would be happy as well.
Yeah.
So now it's going to go search through and find all the cases Giannis makes it. So there we go. So now we got our DF here. Let's filter and find all the times Giannis shots. So it looks like across that first quarter there, Giannis shot 7 times.
Yeah.
And how many times?
4 makes.
Yep, and 4 makes if you look at this Giannis makes column.
Cool.
So there, he's shooting at a 4 out of 7. So he's shooting 57%.
Yeah, and it's only a quarter. So if we were to do this over multiple games, you can actually sum because it's Boolean. R is going to see the true as a 1, and it's going to see the false as a 0. So you could actually apply any mathematical functions that you wanted, like sum up his makes divided by sum up his takes or his shots. And we should get the exact same value, and we do, which means that it worked.
Huzzah!
Boom.
All right, and that is a very quick intro to some regular expressions. Tell us what confuses you about regular expressions so we can really focus on that and really teach you or help you understand what's going on there. Hopefully come up with some good examples to work through that.
Yeah.
Sound good? All right, and I think with that, we're going to call it. Sorry, there's no beautiful pictures this week. We're focusing on regular expressions. All right, and with that, we're going to call it. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward, and I am on Twitter at OSPPatrick, and we are on Twitter at tidy_explained, and we are on Gmail at tidy.explained@gmail.com, and we are on YouTube where you can like and comment on the videos. And
we appreciate likes.
We always do appreciate likes and comments. And you can also open up an issue on the GitHub repo if there is something else that you want to see. Either way, we'd love to hear from you. And we're going to continue with regex expressions next week. So if there's more stuff that you want to see us build upon, let us know.
All right. With that, keep on exploring your world.